Now that we've looked at how to describe scatter plots and the relationship that we're seeing, I'd like to explore this a little bit further. So you'll find on your notes that you have 6 pairs of variables on a page that looks a lot like this, and you'll see them listed on the screen here as well. And what you're going to do is you'll go through and decide, do you think that they have a positive, negative, flat, no relationship? Is it linear or curved? Is it weak, moderate, or strong? And are there any lurking variables that are influencing the relationship between these two variables? Okay, so your answers are going to vary quite a bit depending on your life experience and what your knowledge is of the topic. So don't worry if your answers are different from mine or different from a classmate's. That is totally normal. And that's kind of the fun of statistics, is exploring what could be going on behind the numbers. And so we're going to take a little bit of time to do that. What I'd like for you to do is look at the first one, which is drug dosage and degree of pain relief. And just think about that one for a minute, and then I'm going to go through that one with you. But take a minute to decide how you think pain medication impacts pain relief or not. Okay. All right, so hopefully you gave that a try. And so here I just plotted my axes and put some labels on them, and then I'm going to sketch the graph in. So we were given that the amount of pain medication was the explanatory variable. So if this is the origin, 0, 0, then I would put few pain meds close to that and more pain meds as you went further away. And then same thing, the response variable is the pain relief. So I'd say little pain relief to great pain relief. Right now, as far as what that plot is actually going to look like, well, if you're in pain and you aren't getting pain meds, you probably don't have very much pain relief. So there's probably some dots that sit along here. Probably, or hopefully, if you're in pain, the more pain meds you get, kind of the better your pain relief gets, up until a certain point. So I think that there's a point at which this is going to start to kind of level off a little bit. Okay, and that's either because the pain medication was extremely effective, and so you're at a pain level of about 0, maybe. You have really great pain relief, so there's not more pain to be taken away. So it obviously can't continue. Or maybe there's some sort of restriction on that in terms of like it only provides a certain amount of pain relief due to your diagnosis or condition. So I do think there's probably a point at which this is going to flatten out, which is going to make this be more of a linear to curved relationship. So in statistics or mathematics, I would call that kind of a logarithmic, where you had quick growth and then it kind of leveled off. So we get that positive on the linear piece and then it kind of flattens out. And then I would actually call this a moderate relationship. And the reason for that is that I've done some research in this space of pain medication and pain relief. And typically if a patient complains that they're not feeling like their pain medication is working, they send them for a genetic test. And so in that genetic test, they're looking for which pain med is going to work best with that person's genetics, as well as how fast or slow their metabolism is. So if you are a fast metabolizer for pain medication, you'll burn right through it really quickly. And so you might have a little bit of pain relief, but it's going to wear off pretty quickly. And on the flip side, if you're a really slow metabolizer, then you just never reach that full level of pain medication in your blood. And so it's really not providing the pain relief that it should be. Okay, so those are kind of some things that could go on there. There's actually some new research out on over-the-counter pain medications that shows that they might work better for men than women. So there could be a gender issue there. As well as there's some tie-ins of chronic pain. So there's a lot that could be going on here. And you know, if you just had this part of the picture, that's totally fine. This is really based on life experience and research. Don't feel bad if your picture is different than mine. That's kind of part of what this process is. It's just learning to think about what all could be going on. All right, so you do have 5 more examples on your paper. That next one is calories consumed and weight loss. And why don't I get you started with the graph on this one? It actually doesn't matter which way you draw the graph. They'll kind of look like mirror images of each other, but maybe I'll get you started with the axes on that. So they told us that the calories are the explanatory. So fewer calories to greater calories. And then the response variable is the amount of weight that's lost. So if you lost weight, you're going to be on the positive part of the y-axis. And if you've gained weight or failed to lose weight, you're going to be on this negative part of the axis, either one. All right, so I would love for you to go ahead and pause the video and give those a try, kind of give them your best thought and what your life experience and knowledge base tell you. All right, so hopefully you gave that a try. Let's look at this next one, this weight loss and this calories. So this one might be a little bit controversial, just depending on what you know about this subject. So this idea that calories are related to weight loss is something called CICO, calories in, calories out. And it turns out that it's not actually the best predictor of weight loss, but there is some truth to be had there. So let's start maybe with the parts that we probably all have in common as far as this graph goes. So probably the more calories you eat, like 6,000, 7,000, 8,000 calories a day, that's going to cause you to gain weight. So I would expect to see some points over here. And then you probably have learned at a health class or at some point that if you eat too few calories, your body actually like holds on to what it has. So it's really hard to lose weight if you're eating only like 300, 400, 500 calories a day. So if we have people kind of in that position, they're not losing weight, or maybe they're gaining or losing a little bit, but they're going to be kind of right here. The next part of this is going to depend a little bit on kind of what goes on here. So if you are a bigger person, so like you're taller, have more muscle, you're going to need more calories. And so the amount of calories you eat as maybe as an athlete or something like that, with a lot of muscle mass, you could eat 6,000 or 7,000 calories and you might still be losing weight. So we could get some athletes out here. Whereas if I ate 6,000 or 7,000 calories, we would have to put a mark down here for me, right? So your starting weight, your age, your genetics. So maybe you have a thyroid condition, and so your metabolism is really slow from that. You could have celiacs or something else that influences how your body absorbs things. So there's actually a lot that could be going on. It is generally true that if you eat tons of calories, you're going to gain weight. That's true. If you don't eat enough, you're probably not going to lose weight. So there is some truth in that, but kind of what happens in the middle, there's a lot of lurking variables that could go on there. So I would say that this one, maybe it's a little bit negative, at least in the middle, kind of like the less calories you eat, the more weight you lose. But it's really overall, if you consider from 0 out to maybe 10,000 calories, there's really not a good pattern there. I would say that CICO is maybe weak to moderate, so there is some truth, but hard to say that that's the only source of things that go into weight loss. All right, so come back in the next video, we'll go over the last 4 relationships.